On to question 5, we have a table with some halogen. Halogens refer to elements which are in group 7 or group 17. Okay, so part A say, beside the increase in melting and boiling point down the group, state another trend for group 7 elements. So group 7 elements, they have the color intensity increasing down group 7. Okay, so the color for fluorine, right, is pale yellow. And for chlorine, that's not mentioned here. Chlorine is yellowish green. For bromine is reddish brown. For iodine is literally a black solid. Okay, so you can see that the color intensity is actually increasing down group 7. What is the physical state of bromine at 10 degrees? So if you see 10 degrees is between the melting and boiling point, so it should theoretically be a liquid. Okay, compare the differences in arrangement and movement. So number 1, arrangement. Number 2, movement. Below is melting point when it's a solid. Above is boiling point when it's a gas. Okay, so here when it's a solid, and then here when it's a gas. Okay, so number 1, we need to talk about the arrangement. Then after that, we need to talk about the movement. Okay, first up, arrangement. In solid state, right, they are packed very close together, orderly fashion. Okay, but when it is in a gaseous state, right, they are very far apart in random arrangement. Okay, secondly, the movement wise, they vibrate about a fixed position when they are solid, but when they are gaseous, right, they are free to move about randomly. All right, so that's the 2 points we need to make. Okay, C part 1 says bromine reacts with 11.5 grams of sodium to form 30.9 grams of sodium bromide. Calculate the percentage yield. So first of all, we got to use the mass to help us calculate what is the number of moles of sodium here. Okay, so we got 0.5. We can see that from the mole ratio here, right, 2 moles of sodium will give you 2 moles of sodium bromide. So which also means that theoretically, if 100% yield, right, you should get 0.5 moles of sodium bromide. So just take the 0.5 theoretical yield times the MR of sodium bromide. So by right, this is if it is 100%, 100% yield. Theoretical 100% yield. But in reality, we got only 30.9. So we take 30.9 divided by the theoretical mass that we ought to get times 100%, we get a 60% yield. Alright, so that's how you do part C1. Part 2, fluorine added to the product sodium bromide. Okay, nobody cares about the sodium. It's all about your Br minus, right? So fluorine, since it is more reactive than your bromide, fluorine will displace bromide. Okay, so what happens is bromide will be displaced to bromine. Fluorine will take over the position as F minus in the product sodium fluoride. Okay, so that's for 2. Part 3, sodium bromide has a melting point of 747 degrees Celsius, which is much higher than bromine. Okay, the student claims that ionic bonds are much stronger than covalent bond. Okay, definitely we don't agree with this statement because when you're doing melting, right, you are actually breaking ionic bonds here in sodium bromide, but you are actually not breaking ionic bonds in bromine. You are actually breaking intermolecular forces of attraction. Okay, which is weak. Okay, they are weak compared to the strong ionic bonds. Okay, so the amount of energy to break ionic bonds is much higher. The amount to overcome weak intermolecular force of attraction is much weaker in bromine. Okay, So we are breaking, the distinction here is we are breaking intermolecular forces of attraction and not breaking covalent bonds, right? This is something to be emphasized in. Hi parents and students, I'm Mr. Kwa, founder and principal tutor from Mr. Khemistry. I do these videos to help more students understand difficult chem concepts, and hopefully more needy students who are not able to afford tuition, they can benefit from these videos. Please help me click that like button and share it with your friends so that more students can benefit. Thank you and see you in the next video. Bye.